Welcome to the key concepts for Rotate, the key concepts of the file and the key concepts for the protocol.
Rotate is a really versatile file system. We've got a lot of choice. So we've got 4% tapers and 6% tapers. The instrument has got an S-shaped cross section, and the tapers that we talked about, the taper is fixed across the working length of the instrument.
It's a continuous rotational system. It's blue metal, so heat treated, giving a strong cyclic fatigue resistance and some controlled memory. It also allows for simple sequence. In this case, we're going to be using two files, the 2504 to open up the orifice, and then the 1504 for our glide path file.
So once the opening and the glide path file have been used, what we can do is use the 2504 again as our shaping instrument. Now, as a clinician, if you feel you want to shape a bit smaller or you want to shape a bit wider, you've got the opportunity to do that with the versatility and diversity that this file system offers. So let's have a look at the protocol. The VDW.Rotate is a really simple protocol. So we're going to show you two nickel titanium files. We've got the 1504 and the 2504. Now we're going to use the 2504 initially to do the coronal opening. We'll then use the 1504 to do the glide path, and then we'll use the 2504 again to do the apical shaping.
Yes, and these are the files we're going to use in this step-by-step. We have our size 10 hand file, the 1504 that John mentioned, and the 2504. The size 25 hand file will be our final file to just gauge the size of the apex, and we'll talk about that. These two files have the blue heat treatment, so they have some shape memory, and they will also have a constant taper, which means they're a little bit more efficient and need that little bit more control when they try and take you into the canal.
And I think as well, the way you approach the preparation with a fixed taper file, you really have to focus in on breaking the canal up into a couple of bits. So what we'll look at here with the simulated canal, we've got two parts to it. So the first bit we're going to focus on is the coronal. We need to release the coronal in order then to allow the hand file to get down and then the nickel titanium files to get down apically. It's really important you're quite diligent in that process so that you reduce the risk of the stresses going through that file.
Absolutely. And what we're going to do first is very simply take our size 10 hand file, put a small curve on it, just so that you can negotiate any lumps and bumps or calcifications. You find the orifice, and all you're doing is just trying to find the entrance to the canal and finding out how that canal feels. Is it difficult? Is it easy? And in this case, my file is traveling to about 2/3 of the canal without doing too much. I get to this stage and it's working. Okay, so all I'm doing is some very small watch winding. So I'm not interested to work down there. As John said, we're going to remove the coronal interferences.
So we're going to do that using the 2504. So this is a continuous rotation file. It's going to run at 350 RPM, and we tend to run all of the rotates at about 2 Newton centimeters of torque. So lovely control, but not too overly torqued in terms of the instrument.
And all we're working on is here, those coronal 3 millimeters. So we find the orifice, we activate the file, and it's starting to grab a little bit. 1, and you can see I'm just brushing a little bit on the outstroke. 2, and I'm brushing away from the furcation. 3. So 3 working passes, and it's just painting the walls on the way out. What that does is just it releases the coronal interferences. It brushes away from the danger area, that furcation area, so we avoid any stripping.
And we can see here the irrigant going in. That's really important, and we can follow that now with the size 10. And because Luke has removed those interferences coronally, if we have a look at this instrument, you'll suddenly see it will go down an awful lot quicker.
Just going all the way to the end a lot more easily. So now I've released the coronal interferences. I can put my apicicator on this file and adjust ever so slightly, just turning clockwise to bite into the canal and pulling upwards, biting and going upwards, just to make sure that I've got some patency, that I'm unblocking that canal. And as I get there, my apicicator on, and will start to beep, that continuous beeping. Once I get the continuous beeping, that is my 0 reading. And in this case, there we go, I've got patency there. I get my 0 reading and I measure that. And I will translate that measurement to my glide path file, so the 1504 in this case.
And I think for us, we're very comfortable taking a glide path instrument to our 0 reading. Remember, it's only a size 15 at the tip, so anatomically it's not going to be destroying the constriction that's there. When it comes to the final shaping file, and here we're going to use the 2504, then we're going to finish that 0.5 millimeter back just for that control. So the 10 has gone to 0. Luca's now got the 1504, which is also now going to take to a 0 reading. Bit of hypo in there first just to help with the advancement of that instrument.
Brilliant. So same speed, 350 RPM as I find the orifice. And again, it's 3 working passes. So I've got a 1, 2, 3. Look at that, lovely. Just got to the end really nicely. 3 working passes. Hypo in there. And then get your size 10 back in there just to bring all the debris into solution. Make sure that we've not blocked it. Look at that, that's sliding really beautifully. You can just about see the file just going past the end of that tooth. And that's all we have to do. So just a size 10 in there and hypo again. Now my working length, my final file, my size 2504 will be 0.5 millimeter short. So my working length is 0.5 millimeter short, as John said earlier.
And again, that's just so that we've got nice control of the obturation. We're reducing the risk of the overfill. We know that root canals typically tend to be more successful if the root filling is contained within that 0 to 2 mils from the radiographic apex.
Yeah. 2504, 350 RPM. Again, 3 working passes. Let's see if we get to length. So we've got 1, 2, 3. I'm pretty much at working length on that 3rd pass. I tend to hit working length with these instruments, and that's it. I don't tend to go back to my working length.
Yeah, and I think with something like the VDW.Rotate file, because it is a blue wire, because it's got a strong cross-section, the S-shaped cross-section, it is fixed taper. It creates quite almost like a confident shape at the end of the root canal. So yeah, I agree with Luca. It's hit length and come out. Don't linger there.
Yeah. Again, size 10 in there just to make sure everything's nice and open, nice and clean. Fantastic. The canal looks clean, excellent. And then what we need to do is check 2 measurements in a canal. You have the length, which was our working length, and you have the apical size, the gauge. We just use a 2504 file. So we're going to use a size 25 file to just make sure that the apex of the tooth is what we want it to be. My size 25 is measured at 25 at my working length. And what we do is we just place it to working length, put a little bit of digital pressure just at the top of the handle to make sure it doesn't slide through, which confirms that my preparation is at my working length and the apex of the canal is at 25. Yeah. So I'm confident that I can pick up my chosen cone to place it in the right place.
So I think we can see it's a reasonably straightforward protocol. So we're just using 2 nickel titanium files. We've got the 1504 and the 2504. If your preference is to go a bit bigger, you can use the 06 taper that the VDW.Rotate offers. And again, it's got a huge diverse range of instruments, so you can treat a massive variety of cases with this. We've got additional videos where we'll be showcasing the full file system. So if you're interested to look at that, please dive deeper.